welcome to PhysChem with Liz. I'm Liz and this video is part 2 of the ideal gas equation. So in the first video we addressed the first two learning objectives. We looked at the ideal gas equation, we looked at some units and their conversions, and we explained the difference between a real and an ideal gas. Now in this video we're going to actually apply the equation. We're going to look at rearranging it and practicing those unit conversions. Okay, so our first question, we're going to calculate the pressure. It says, what is the pressure exerted by 2 moles of carbon dioxide in a 10 meter cube container at 0 degrees? Give your answer to 3 significant figures. A question like this will typically be 2 marks. So the first thing we need to do, we need to look at the values we're given. Does anything need converting? So moles is in moles. Our volume is in meters cubed already, so we don't need to do anything there. Our temperature is in degrees, so we need to add 273 to convert that into Kelvin. So that would be 0 plus 273 is 273. Okay, then we need our equation. Is PV equals nRT, and we need to rearrange it to make pressure the subject. So how do we get pressure? By itself, we divide by volume in order to isolate the P. Whatever we do to this side, we do to this side as well. Therefore, P equals nRT over V. Now we just plug in the numbers. So N is 2, that's the number of moles. The gas constant you'll be given in your data sheet is 8.314 joules per Kelvin per mole. Temperature is 273 Kelvin. And our volume is 10. And then we just pop that in our calculator. So 4539.444 divided by 10, and that is our answer. So it says give your answer to 3 significant figures. So that will be 454 rounded. So our pressure is 454, and it's going to come out in pascals because that is the SI unit of pressure. Our next question is a little bit more complicated because there's more that we need to convert. So in this question, we're asked to calculate the amount of gas in moles. We're given a temperature that's already in Kelvin, so we don't need to do anything with that value. We're given a pressure in atmospheres that we need to convert into pascals. And we're given a volume in litres that we need to convert into meters cubed. And again, we have to give our answer to 3 significant figures. So it's about 2 marks. So the first thing we need to do is look at our conversions. The conversion that we need to learn here is that 1 atmosphere is equal to 101,325 pascals. We're given 560 atmospheres of the pressure, so we just times the number of pascals in 1 atmosphere by 560 to get our pressure. Then with our volume, 25 litres, we need to know that there are 1,000 litres in 1 meter cubed. So to get from litres into meters cubed, we just divide by 1,000 and we end up with 0.025 meters cubed. Then we rearrange in terms of N, which is moles. To isolate N, we need to divide by RT, because you can see it's times by it. So to cancel it out, we need to divide. Whatever we do to this side, we do to this side as well. So we end up with N equals PV over RT. Plug our numbers into the equation. That's the gas constant. There's our temperature. And we end up with, to 3 significant figures, 143 moles.